A quadratic equation is a second order or second degree polynomial set equal to 0. For example, 6x squared plus 2x minus 3 equals 0. Or maybe x squared minus 9 equals 0. Sometimes the first term is not present. The first degree term is not present. We can factor these expressions. For example, x squared plus x minus 6. So, if we look at this, what times what equals minus 6? Well, the factors of 6 are 3 and 2, 1 and 6. I'm guessing here 3 and 2 look good, because if I have a 3 and 2 here, then I can get a positive x if I make this plus 3 and this minus 2. So you can back calculate this, and you should get x squared plus 3x minus 2x minus 6, which is x squared plus x minus 6. One of the reasons to factor some of these relationships is because once you have them in factored form, it's easy to solve the equation. So for any quadratic equation set equal to 0, there will always be two answers, although not necessarily two real answers. You could have two imaginary answers, but there will always be two answers. So to figure out what the solution to this is, we'll have to have a situation where x minus 2 must equal 0, because 0 times whatever x plus 3 is will equal 0, because it's 0 times whatever this number is equals 0. That, or x plus 3 must be equal to 0. So we can individually solve these, set them equal to 0 and solve them to determine what value of x will solve this equation. So, for example, first relationship is x minus 2 equals 0. So x equals 2. Second relationship to make this equation equal to 0 is x plus 3 equal to 0. So x equals minus 3. So solutions to this quadratic equation of x squared plus 1x minus 6 equal to 0. Solutions to this are x equals 2 and x equals minus 3. So let's see. Let's try it out. Make sure that they are solutions. So we've got 2 squared plus x minus 6 equals 0. So this left side should equal 0 if this works out. So let's first stick in 2 and see how this does. So we get 4 plus 2 minus 6 equals 0. That's correct. Okay, now let's try minus 3. Minus 3, minus 3. So we got minus 3 squared is 9, minus 3, minus 6 equals, well, this is 9 minus 9 equals 0. Correct. Not all quadratic equations are easily factorable. You can look to the chapter section for some ideas on how to factor different types of quadratic equations. However, something that I'm going to show you right now will always work, and that's called using the quadratic formula. So for any quadratic equation, ax squared plus bx plus c, where a is a constant coefficient b is a constant coefficient, and c is just a constant, we can set up this relationship here. And we'll get two answers because this is minus b plus or minus, which will get us our two solutions. So let's go ahead and try that on the equation x squared plus x minus 6 that we just solved. So in this equation, a equals 1. It's 1 times x here. B equals 1, x squared here, I mean, 1 times x here, and c equals minus 6. So our relationship then is minus b minus 1 plus or minus the square root of b squared, or 1 squared, minus 4 times a is 1, and c is minus 6, and then the whole numerator here divided by 2 times 1, or 2. So this equals minus 1, plus or minus, let's actually make this minus 1/2. We'll split this into two fractions, plus or minus the square root of 1 minus, so 4 times 1 is 4, times 6 is 24, it's minus 24 times minus 1, so plus 24 over 2, which is minus 1/2 plus or minus square root of 25 over 2 equals minus 1/2 plus or minus 5 over 2 equals, so minus 1/2 plus 5 over 2, so we're going to have two solutions. It's going to be 4/2 and 6/2 minus 6/2, when 5 is minus 5 over 2 minus 6/2, which this equals 2 and this equals minus 3, and we see that's what we got when we factored this up here. X equals 2, x equals minus 3. So why does this quadratic equation work? Well, it works because these equations represent geometric shapes we call parabolas. A parabola is something that looks like this. This is the graph of the plot x squared plus x minus 6 on a Cartesian axis system. So here's x, here's your y scale. And what the quadratic equation does is, and here I've taken the quadratic equation and I've split it into two fractions, which I can do. But what the quadratic equation does is it calculates every one of these parabolas has a vertex, and it's right here. And it's either the highest point or the lowest point, depending on whether or not this is upside down or right side up, if these are vertical, up facing or down facing parabolas. And this value here, you see this x value is 1/2. And that's our first term. Remember, minus, because b equals 1, a equals 1, and c equals 1. So minus 1, this is a minus, minus 1 over 2 times 1 is minus 1/2. So this minus 1/2 represents the x value of the vertex. And then this portion of the quadratic equation is just the distance to where it crosses the x-axis, if it crosses the x-axis. And if it does cross the x-axis, if your parabola crosses the x-axis, you get a real solution, like we did. So you can see here it crosses the x-axis at x equals minus 3, x equals 2. And this makes sense because you set the equation equal to 0, which means your y value is equal to 0, and that occurs on the x-axis. So this is where you cross the x-axis. So it's the vertex 1/2 plus or minus the distance to where it crosses the x-axis. Okay? So you might ask, well, what about a quadratic equation that looks something like this? Set equal to 0. Try to factor this. I'm trying to think, that's tough to factor. Let's go ahead and plot it. If I plot that relationship, it looks like this. It doesn't cross the x-axis. Well, what the heck is happening there? So again, label these scales. This is your y-axis. This is your x-axis down here. This will never cross the x-axis. But it still is factorable. And if we put it into the quadratic equation with the values of a equals 2, there's now 2 times the first term. B equals -1, there's -1 times the x term. And then c equals 2. So putting these values in, x equals -1 plus or minus the square root of 1 squared. It's actually -1, but it can get the same value. -1 squared minus 4 times 2 times c is 2 over 2 times a is 2 is 4. So then we end up with 1/4 plus or minus the square root of 1 minus 16. 4 times 2 is 8 times 2 is 16 over 4 equals, and now we see what the issue is. 1/4 plus or minus the square root of -15 over 4. This is going to be, well, this whole thing is going to be a complex number, and this term is going to be imaginary because we've got the square root of a negative number, square root of -15. So this equals 1/4 plus or minus the square root of 15 times I, square root of 15 over 4 times I. So we have our real and our imaginary component in this complex number. And notice they're complex conjugates of each other. So one is 1 plus square root of 15 over 4 times I, and one is, so our two solutions are x equals. So you'll always get two solutions, and like I said, these are solutions to the problem, complex, but they're complex numbers. So you could take either of these two complex numbers, stick them back into this equation, work it out, and it should equal 0. So here I've done that. I've taken the first one, x1, and I've stuck it back in this equation, set it up to multiply out, and see if the left side equals 0. And here I've worked this out, so you can see that the complex or the imaginary terms cancel out, and eventually you get down to 34/16 minus 34/16 equals 0. So you see that it does work. So I challenge you to go and take this term and do the same thing I just did and see that it comes out to equal 0 when you stick it in this equation.